Okay, here we are in part three of this math trauma video, and we were getting into the solutions, like what are we supposed to do about it? How do we better deal with math? And there are five solutions. The first she just got finished discussing was attend to it. In other words, pay attention to it. Acknowledge the past negative experiences that we've had, and then tell our stories, guard against negativity, and form our own math identity. So let's see what the second uh, proposal is.
So the second piece is about our classroom culture in math. So math needs to become a place where everybody wants to be. And part of that is this emotional safety piece. A lot of it is being known and respected for who you are and what you bring to the table in terms of the mathematical activity. So kids need to know each other. They need to know each other's names. They need to have a sense of their learning styles and their interests. Our elementary colleagues tend to do a really nice job of this. For those of us who are teaching sometimes hundreds of students in one day, it can be harder, but I actually would argue that it's even more important to invest in the community so that the kids within the class actually know each other. With my pre-service folks, I encourage them in late October to ask their classes to do a faux pop quiz where you have the kids in the class see if they could name everybody in the class and one thing that you know about them. And they're always really surprised at how many high school kids can't do that. Mistakes, of course, need to be seen as opportunities to learn. I think our field is really talking about this a lot in terms of Joe Bowler's work, Carol Ducksworth's mindset. I think mistakes are on the horizon. But really, if mistakes are still bad, if mistakes are a source of shame, it's going to take a lot for us to get people moving in a positive direction and in a positive emotional state. Mistakes really need to be celebrated as something that's interesting and that helps us think a little bit more deeply about the mathematics. Kids need to be able to appreciate each other and what they bring to the table. And this is going to require us as teachers to structure our daily activity a little bit differently, in that we want kids to be collaborating and taking responsibility for their own learning. We want to have the opportunity to really expand what it means to be successful in math. If math is all about reproducing procedures created by other people as fast and as accurately as you can, it's only going to be fun for a couple people. It's really not going to be fun for everybody. So we need those complex tasks. We need kids to be doing authentic work, that, collecting data, exploring issues that are important to them. And we need to be really proactive about assigning competence to students that we know have low status in our math classrooms. So we want to be on the lookout for those kids who are judged by their peers as maybe not contributing as much as somebody else, and see the moments when they do something really wonderful by maybe asking a good question, maybe helping organize the data in a table, maybe getting their group back to work, whatever it may be. We want to try to give status to all kids so that they all are feeling like they're mathematicians, right? And that's how our classes will really work the best.
Okay, so in other words, especially appreciate each other as resources, get to know each other's learning styles. I feel, tell me, maybe this isn't your experience, but it seems like a lot of times when you guys work in groups, and of course I never talking about you specifically, but when teenagers work in groups, a lot of times the only way that they see each other is, oh, he works hard, he doesn't do any work. And that's just sort of this, and there's a fight about that. But what you might notice is that you, person who think that you're a hard worker, in actuality, you have a gap in some area that you could get help in. And you other person who thinks of yourself as lazy or not a good worker, you actually are a good worker if you're just willing, if the assignment just changes a little bit, or if we find the right job for you. So when you say somebody's a good worker or not a good worker, you're probably being overly simplistic. It's probably more complicated than that. And you need to learn each other's strengths and weaknesses so that you can work together and find each other's best parts as groups. That's how great teams operate. They each bring out the best in each other. Okay, so now let's see, learn a little bit. There's a third strategy. So the second strategy had to do with what we just talked about, which was prioritizing classroom culture. But now we're going to talk about
all are feeling
actually learning
like
about the
they're
brain.
mathematicians, right? And that's how our classes will really work the best.
Learn about
We
your
also want to teach kids about their brain. So this thing, the amygdala, is a really powerful filter, and it's very deep. It's part of our limbic system, which means it's our mammal brain. And the thing that we're learning about the amygdala is it becomes very sensitive to repeat negativity. So the more negative experiences a kid has, the more the amygdala is going to trigger the whole fight or flight mechanism. So we need to teach them that that's happening so that they can sense it and begin to do. We could talk for hours about some of the things that they can do to regroup. And some of it is what's been written in those self-help books, right? I mean, I think there was some intuitive, it's the deep breathing, it's getting up from the situation, it's having a conversation about the problem with a peer, getting a chance to think and write before you have to turn and talk. But the amygdala will limit access to the parts of the brain that our kids need most to do math. And they need to know that that happens too, so that when they're feeling bored, when they're feeling frustrated, they're at risk of tripping that filter. They also need to know that they can grow their brains, that this idea of math smarts being given is not true. It's cultivated. And if you want to grow your math brain, you can. For the age group that we all teach, I can't stress more strongly, the importance of movement. So our brain expects us to move, and we have become a very sedentary culture. And for those of us who teach middle school and high school, these periods that are like 90 minutes long, kids need to be moving in all of those lessons. I think it would be great if they could move every 25 minutes or so. They absolutely have to move every 45 minutes. And if they don't move, that begins to manifest in their brain as this boredom, frustration, checkout.
So just just to review that, this part of the brain that filters our activity sometimes makes us oversensitive to repeat negativity. So if something doesn't work a couple times, we give up. So in other words, it's bad for our persistence, for our resilience. This is a key quality: persistence, resilience, to succeeding, not just in math, not even normally in math. You would hear this quality talked about a lot when you're talking about like the Warriors and why are the Warriors so good? Because they were down 3-1 to Oklahoma City. That's 3 failures, 3 negative experiences. You think they might have just given up, but apparently they developed this quality of persistence and resilience. But the amygdala is that part of our brain that seems to like overdo this, relive negativity so much that we don't get up, that we don't give up. That's why what the Warriors did was remarkable, because so many people do give up. So many people, they experience that negativity. It feels so traumatic, and they're like, I'm not going to try that again. So it's normal, and yet you want to try to overcome it, develop this quality of coming back against it, but know that it's going on in your head, and not just your head, but most people's head. This is a funny thing that happens that makes us not try stuff, and when we don't try stuff, we can never succeed at it. That was probably a little more of a digression than I meant to make. This neuroplasticity, it refers to the neuro means the brain, and plastic means, in this case, plastic means, uh, movable. Uh, the brain is movable. It changes over time. So intelligence isn't just what it doesn't stay the same as what it was when you were born. It changes over time. It grows. And then, yeah, the importance of movement, which basically means, hey, Mr. Dittmer, we've been sitting for 45 minutes. You said at the beginning of the year that our brain needs us to move, that our culture shouldn't be so sedentary, sitting all the time. So, hey, Mr. Dittmer, can we get up? Can we walk around? Can we stretch? You guys get to ask that. That's reasonable. All right. This next slide, I'm gonna sort of try to skip her talking about it, but she basically says her third solution, or maybe this is her fourth solution, is to advocate for struggling students. In other words, maybe you guys have heard of ELL, where a few students are pulled out of class just to talk about English. Well, she started saying there ought to be something like that for students who are struggling in math. It deserves its own category. To be math traumatized is a serious thing. And so there should be a way to make those students who need that help the most get the best help, resist blaming students and families for failure. So as a teacher, constantly just be an advocate for, so, that's more of a teacher slide than one for you guys. And then end traumatizing traditions. I think this is going to be our last slide here.
Any failure that they might be experiencing. And finally, I would love to see us end some of these traumatizing traditions. I'm going to talk about a couple that I think are just so critical. So one is what I call one-shot only assessment. It's less common now, but it is still more common than it ought to be for kids to have quizzes and tests where they're timed, they get to take it one time, there are no retakes, there are no test corrections, and that's their only chance to show us what they know. I'm not sure we really do that in any other our tracking and ability grouping, it puts those labels on people that are traumatizing. A number of those trauma stories I talked about, talk about being put in the low math group, and therefore being put with the same group of kids all day. So tracking in math ends up tracking other subjects which are not tracked, but because of the kids being grouped for this one subject, it ends up affecting how they flow through the rest of their day. The other piece here that I think is worth mentioning, and then we'll focus on where people have passions or questions, is this notion of if we are focusing on procedures and sort of classifications of problems as opposed to problem solving, it becomes really easy for kids to see math as this replication of one right way, as opposed to thinking about multiple ways to one right answer. I tell my graduate students all the time that they're not allowed to turn in a problem in my classes unless they can do it three ways. And they come to graduate school, they can do one, oftentimes they can get two, and in the beginning it's really hard for them to come up with three strategies for any problem that we do. By the time they leave, they can generate a half dozen or so. But this idea, the language we use sometimes around step by step and things like that can really contribute to kids just feeling that math is all about rules and mastering the rules, and it isn't about thinking, it isn't about creativity. And if those things are missing, I think we're going to continue to have traumatized kids. So big picture implications, and then we'll take any other.
So that's where we'll stop for today, just with that last notion of math is not just about following rules and step by step. There's creativity to it also. so there couldn't just be one right way if it's about creativity. Thanks for watching.